Okay, so this one is kind of a tie-in of a multiple concepts that I've been building and a sort of abstraction from them, or maybe not just an abstraction, but also an extrapolation from them. This is subject to scrutiny, all right? This is something that I'm not on the most confident side about, but I feel like is the logical conclusion and the path forward for, just us in general, I guess. Right? So, first we'll start with the explanation maybe. We'll see where this takes us. All right. Too much energy in one spot can make a black hole, and that is why we can't see things beyond that limit. If that makes a black hole, then what do we think a black hole is at a larger scale? They're the same thing, as I have been saying, right? So, this is why they formed first. Energy was high and concentrated, and so the extreme energy density formed small black holes. These black holes then reduced the energy density and began to pull in the energy that wasn't initially consumed. This is when stars started to form and then galaxies materialized, and is probably what we observe in the red dot galaxies we see and the stages of them aging into green peas and then into blue dwarfs over time. We see an increase in wavelength with relation to Hawking radiation and size, and this would make sense. And this would make sense. And the strong gravity and high dark matter radiation probably act as some sort of balance act, just like stars collapse when they run out of energy to push out against gravity with. These massive black holes are beaming the stars with dark matter radiation that is holding them in place and preventing them from colliding or combining. This is again similar to the process of protons or hydrogen forming and then complexity building from there. So, it kind of gets into some interesting stuff. So, the initial thing to start off is basically if you look to something too large, you get a black hole, right? If you put too much in one spot, you get a black hole, right? If you look down, right, and in order to look down, you got to beam it with enough energy. If in order to see that far down, right, if you beam it with too much energy at that small scale, you create a black hole, right? So too much energy, you create a black hole. Too much mass, you create a black hole, right? The thing is that what's the difference between these two things, right? What is the difference between these two things? They're both black holes, right? So if that's a black hole, right, and this is a black hole, what is the difference between this black hole and that black hole, right? This one was made with just pure energy, right? That one was made with pure mass. What is the difference between these black holes? Do they behave differently? No. Right? What is the difference between these two black holes? And my conclusion here is that there isn't a difference, right? There's no difference between the black hole up there and the black hole down there, right? And so what I'm potentially saying with this is that if the limit down is a black hole and the limit up is a black hole, right? Then if we want to see farther down than what the black hole lets us see, right? Because we form a black hole if we look too far down. So if we want to see farther down, then we may just have to start looking up, right? And I know that sounds crazy, but one of the talks that I recently did that I kind of said as didn't think it really was going to have any, I thought it was a weird thought and I wanted to say it just to say it, but I didn't think it was really going to tie into anything. But this talk that I'm talking about is why does red and blue make purple? And when you look at this, right, you look at colors, right, you can create the color wheel, right? And that's a perfect ring, right? It's a full ring it's a complete loop. You put all the colors there and you can blend them all together and they all merge and it completely fills out the whole loop, right? It's a whole loop around. It's not a line necessarily. You can bend it around and it forms a loop, right? And it works, right? And so, what I think is interesting about this and what I've said in the past is that when you look at the electromagnetic spectrum, right, and you look at the range of visible light, you have red and you have blue, right? And then after blue comes violet or purple, right? And then, so when you look at them like that, right, you mix red and, we'll say yellow, and you get orange, right? You do blue and yellow, and you get green, right? They meet in the middle. All the other colors meet in the middle. But when you do red and blue, you get a color that's actually after blue. It's not in between red and blue, right? Because realistically, if you mix blue and red, you should get green. Like that's what makes sense, right? But you don't get that because green's in the middle, right? It should it should be green. That's looking at everything else, I feel like that's the logical conclusion. Red and blue make green, but it doesn't. But it doesn't make green. And I think that that's interesting because everything else behaves like that, right? Except not with this, right? It doesn't behave like that for these colors, right? Then the pattern doesn't work. But if you bend it around and make a ring, then it's no longer weird, right? Then it makes total sense. Obviously, if you mix blue and red, you're going to get purple because they're right in between, right? Purple's the only color in between them, or violet, right? That's the only thing that's in between red and blue. So obviously that's what you get, right? And now it makes sense. And my explanation for a potential reason why this is what we see and this is how it works is because, it's a mix of, that's, blue and the color I can't see. And red also has this color you can't see factor to it. So when you add red and blue together, right, the red basically gets overpowered because it's a lower wavelength. And so we look at the blue and we go, oh, well, that's blue. And then there's also even more of this whatever color where I can't see. So the infrared light that's coming off of this red, right? So it's red and infrared coming off of this red. And then we have blue and ultraviolet coming off of this blue, right? So when we mix these two together, we get infrared and ultraviolet mixing, which are two colors that we can't actually see, but because we can't see them, we're like, the photons are still hitting our eyes. We just don't perceive them, but I guess we kind of can, right? Potentially, right? And so because we kind of can perceive them, we go, oh, well, that's the color we can't see, right? And, our brain basically goes like, well, I can't see anything past this point, right? And I can't see anything past this point. So I'm going to just connect it, right? And basically just, it creates purple, this like bridge color before it goes back around, right? And I think that is very interesting the more that I think about this now, because the reality is that, maybe, that's the size I can't see. Oh, that's the size I can't see. Well, what happens when, you want to see that? Okay, well, you just you complete the circle. You make it a loop. It's no longer a straight line. It is a loop, right? And so, I think I have more on this. Yeah. I do. If you look at something too small, you get a black hole. If you try to look at something too big, you get a black hole. For this reason, I think that it may be practical to say that if you want to know what happens smaller than a black hole, look up. And if you want to know what's beyond a black hole, look down, right? I know that this may be crazy, may be a crazy statement, but it brings everything within view, and builds infinity with a finite loop we can observe and extrapolate, and allows for understanding of everything without actually needing to see it, right? So this ties back into my talk about what makes red and blue look like violet or purple. I had said that it was potentially because our eyes saw both ends of the spectrum as the color we can't see, but what if this is actually an incredible insight by our eyes in a turn of irony? Our eyes could see what we could not. That what is below is no different from that which is above, and that it is actually a loop, as the color wheel shows, and not really a line. The reality being more like a spiral staircase, where the above view looks like one circle, but the side view can see you are changing levels or floors as you traverse it, right? So what I'm saying with this is that I think that that's actually quite funny. Basically your eyes kind of put this together, and a part of us could see the connection, but we were blind to it. And I love that. I love that so much. Oh my gosh, I love that so much. That's so funny. And it's just, it's so poetic in a way. But what I'm saying is that it's not that you look up and that black hole is the black hole down there. No, that's not exactly what I'm saying. I'm not saying that our entire universe is one big circle. Not necessarily. What I am saying is that if you want to understand the behavior of what is beyond black holes, right? Then start looking down at atoms, right? And what the behavior you're seeing with atoms is what's happening with black holes, right? And is what is happening beyond what we can see. And then if you want to see what is, smaller than black holes looking down, right? Smaller than what we can possibly observe looking down, then start looking up, because the behavior of, stars, black holes, planets and stuff in the universe, that is what we are missing down that way, right? So using this logic, we do not need to see any further, because everything is within sight, right? If we just look at everything, we can then understand and then extrapolate it down different levels. Because like I said, we're on this one level, right? And we can see the level above us and the level below us up to a point, right? But if we want to see another level down, we got to move down a level, right? But we can't move down that level. And since we can't move down that level, well, we can assume, okay, well, if this level is this, then, the next level is going to probably look like the one above us, right? Because if we were on that level, right, or we were 2 levels down, in theory, everything looks the same. It doesn't look like we moved anywhere, because it's an infinite spiral down and up, right? So there's no way to actually tell where you are on the staircase, right? You know that you're at the level you're at now. You know that is real to you, right? But you don't know exactly what's on the next level up, but you can kind of see what's that. You can see that there's one there, right? But after that point, there's hints that there's maybe something beyond that, but you really can't quite see it yet. You got to move up more in the level to get that, to actually perceive those levels. But again, we can't go there, right? So since we can't go there, right, everything looks the same, right? It's infinity up and down. And since it's infinity up and down, it actually doesn't matter where you are on the staircase, because the behavior that you're observing will be the same, wherever you go, right? You go down a level, okay, well now that level that you're at, that is the material world. The one above you, that's going to be dark matter. The one below you, that's going to be dark energy. And nothing changes, right? What was once solid matter to you is now objects so large you can't see and could never even perceive their behavior, right? You could never even, like, being at the atomic scale, you would never see a person, right? You would never be able to look out and go, oh, that must be a person there. You would never be able to do that because you're literally just looking at empty space. Because if you are that small, everything is empty space. And that's pretty much what I'm trying to get at here. And so I think that this is, potentially crazy, but also actually makes total sense because it gives us a unified theory of everything without us having to go any farther. We don't need to see deeper. We don't need to see out more. Everything is here already. We already have everything we need. We just need to understand it better. And I think that makes the most sense. I don't think anything else makes more sense. I don't think anything could. Because with this concept, yes, there's further understanding to be had, but there's no limitations, right? We're not restricted by, we just can't see far enough. That doesn't matter anymore, right? It's not about how far you can see. It's just about what you do with what you can see, right? That's what matters. And I think that's also just an important thing in general, just a life thing. Don't think about everything that you can't see or everything that you could see. Think about what you are seeing, right? Don't think about what's not there. Think about what is here, right? And I think that that's, just a good life lesson. If I said that quite right, I might have messed it up a little bit. But, if you're understanding what I'm saying, then I think you understand what I'm saying, right? So, a little bit of philosophy in there for you. But I really think that at some level, this physics is a theory of everything, right? And so philosophy naturally falls into this, right? Because when you're theorizing about everything is a part of it. I don't know if that was necessarily the best wording. I don't know. But it's really hard not to get philosophical when you think about the reality of the universe, right? When you're trying to understand the fundamental workings of the universe, it's really hard not to think about how that impacts you and how you live your life, right? Because when you understand the universe, you have to understand yourself. You have to, right? And if you don't understand yourself, you're never going to understand the universe. Right? You got to start somewhere. Don't go diving into the ocean if you don't know how to swim. So, yeah. I think that's all I got to say. Peace out.